My name is Grace Peng, and I'm also a government agent, and I want to thank you for your taxpayer dollars. I am a steward of your taxpayer dollars, and I'm very happy to see what it's done in the MD PNP. And I'm here representing the National Institutes of Health, and within the National Institutes of Health, the NIBIB, as well as the Office of Data Science and Strategy. And just quickly showing the slide, the ODSS, the Office of Data Science and Strategy. If you don't know about this office already, you should look it up, because if you look at the graphics, it's doing everything you're talking about in terms of data: findable, accessible, interoperable, reusable, and trying to create different opportunities to interconnect different researchers through data science. In my own institute at the NIBIB, our goal is to support technology at the NIH, technologies to shape the future of health. And this graphic is from our current director, who likes to show how modeling and computation sits in the center of biomedical imaging and bioengineering. And so NIBIB, as Julian mentioned before, supported the NIBIB quantum projects. And I actually looked up in our database, Julian, you were right. And so the quantum project funded the MD-PNP from September 30th, 2010 to August 31st, 2015. And so it's so wonderful to see the outcomes of that project, because if you recall, the goal of this initiative is to achieve a profound quantum impact on the prevention, diagnosis, or treatment of a major disease or national public health problem. I think you've actually achieve that goal. So congratulations to you and your whole team. And I looked up the program officers too. We started with Zohar Cohen, and then it came to me, and then James Lowe had it, and then Vinay Pai. So we had a village behind you in terms of managing your grant, and it was amazing to have you in this portfolio for the quantum project. So I'm going to one-up Sandy's slide, because this is the CDC slide from 2020. So this is during the pandemic. You can see that medical errors actually was bumped down to number 4 after COVID. But if you look at the age spans, medical errors is still number 4 after heart disease, cancer, and COVID. And so this is still a continuing problem now. And the data hasn't changed. And that's what motivates us at the NIH. And so far, we've been talking about medical devices and medical data associated with devices, and that's super important. My own portfolio at the NIBIB really is to think about how we can analyze data through models and computation. And this was back in 2012. There's this very nice mapping of all the devices that could be, all the things, the biomarkers in our bodies that could be measured, and how we could analyze them using models, and how we can look at it from the systems of humans. So the goal of my talk actually is to talk about the 2 S's in SaAMS, the smart part and the systems part. So I want to say that I've been promoting multi-scale systems of the body. If you look at our body below the skin, it's very complicated, from genes to proteins to cells, tissue, organs, all the way up to the body. And there are so many interacting components. And then you look outside above the skin, you have the individual, interpersonal community, all the way up to populations. And so we have been trying to have NIH understand health from this whole multi-scale perspective. And I run the multi-scale modeling consortium through the Interagency Modeling Analysis Group. If you'd like to come to our meeting, we have one this fall to talk about digital twins. But I want to implore to you to think about systems. You've all thought about systems from engineering systems, but to think about the system that's within our body and why it's so hard to talk about understanding our body, because it is so complicated. So I actually implored the community that studies lower back pain to tell me what is the cause of lower back pain. And they spent years developing this paper, which is an amazing paper where they really brought clinicians and engineers together to think about the system of back pain. And the top shows the illustration of the different components that you might think about when you think about engineering models, but the lower portion shows the social, behavioral, psychological, and patient-specific functions. And so the idea is that we really need to understand the mechanisms, because mechanisms will reduce the uncertainty of the unknowns. I'll move on. So the whole idea of this is to say that we can't just consider medical devices and medical data, but all the linkages of the whole system, from where we start with the patient to what we do in the medical care to the overall well-being of health. And so I'm going to go through a few bridge programs that I'm currently involved in. The NIH Bridge to AI program actually is to think about creating ethically sourced data for future AI ML models. And that's where the first S comes into play with SMART. Everybody talked about how AI is going to help this and how AI is going to help that. I'm actually going to bring a little bit of a downer on that message, because AI is only as smart as the data that you put in there. And so actually AI is quite dumb. And we need to have, and why does everyone say, well, we need more data for better AI? If you have really bad data and more bad data, you're going to make really bad AI. And so the whole point of Bridge to AI is to create pristine data, which means we consider the ethical principles surrounding everything that I just showed you in that system, the context in which a person has lower back pain, the social behavioral consequences, the social determinants of health, the context, the consent, all those things all come together in the context of one data point. And if we can make a lot of that kind of data, that's good data, that's AI ML ready data, that's what Bridge to AI is all about. And it's creating these best practices for making these smart data. So that's where smartness comes in, is when you feed mechanisms and when you feed ethical principles behind the data in order to create a smart system. And so ethical principles, keeping that in mind. And so Bridge to AI is driven by these grand challenges, and we picked these grand challenges to look at all sorts of data types and to think about the ethics behind these data types. I don't have time to go through this, but they are looking for external partnerships, and you're welcome to contact me to talk about it. But Bridge to AI is all about instilling the culture of ethical inquiry. It's not just about IRB, it's about this whole culture and the whole pipeline. And to think about multimodal AI in terms of fusing multiple data types together for AI. But again, the multiple data types need to be developed with standards, collected with standards, and thinking about ethical principles throughout the entire process. We have another program called MIDRIC that actually is the medical imaging data resource center that NIBIB supports. And they actually went through a whole exercise to figure out all the biases that occur when you're preparing data. There's 40 some biases here. And they actually have a bias calculator. So I encourage you to look at the bias calculator in the MIDRIC program on how bias affects the data. So ethics and bias all wrap up together. And finally, I'm also involved in this new program called COMPASS, which is to, for the first time, NIH funding community partnerships to advance science for society. And through this, we actually give the awards to the community organizers to create structural interventions to reduce health inequities. And from there, you learn more about community health and how medicine practiced in the Western world really is taking away from the community. It's more focused on individual health. But if you think about the community, you have a whole different way of thinking about your stakeholders. And so we funded 25 projects that cover these different structural factors and social determinants of health and health disparities. I encourage you to look at the QR codes. I'm happy to share these slides to look at COMPASS and see what these community organizers relay about how they address their community's problems and how these stakeholders, through other methods such as storytelling and through other methods of community building, address their community health problems. So I wanted to go to this, which is take a picture of this QR code. This is a NASEM report for foundational research gaps in digital twins. It just got published in December. And my group in IMAG, the Interagency Modeling and Analysis Group, is dissecting it like crazy. As well, we have a new White House initiative to create a roadmap for digital twins, the Fast Action Committee. And this is an amazing report that they did for a year and a half. And they created this definition of a digital twin, which, again, there are many definitions out there, but this definition really thinks about the mechanisms between the dynamics between the virtual world and the physical world. So a digital twin is a set of virtual information constructs that mimics the structure, context, and behavior of a natural, engineered, or social system or system of systems, is dynamically updated with data from its physical twin, has a predictive capability, and informs decisions that realize value. The bidirectional interaction between the virtual and the physical is central to the digital twin. And that's where a lot of what we talked about so far is what you all would like to do in SaAMS. And so this graphic is also very important between the dynamics of the physical world and the dynamics of the virtual world must interact bidirectionally in real time with ethics and security wrapped all around it, as well as verification, validation, and uncertainty quantification throughout the entire process, because both assets change. So if you have a physical asset that's controlled by a virtual asset, that physical asset will then change its properties to change the virtual asset, and so on. So you need to think dynamically, and you need to think dynamically within the system. And this is how you create the S and the S in SaAMS, right? With both the smart and the systems. And so before the NASEM report, I actually outlined what you should do in terms of how to create a digital twin. And I really do think that SaAMS is probably positioned very well to do this in terms of thinking about this and the ethical issues in the context of data. And we actually tried to put out an initiative on digital twins prior to the NASEM report. And we actually were not very successful because people did not have the appropriate mindset of thinking about what needs to be predicted, what can be modeled and simulated, what measures can be captured, is the technology in existence, what are the ethical issues? And if you think about mapping the NASEM report on top of that, they strongly talk about fit for purpose to define the resolution and the fidelity of the digital twin. Depending on the fit for purpose, you will then define the VVUQ and the dynamic assets, the bidirectionality of the real-time data, the interoperability, and the democratized access to all. So it's a very, very hard problem. I encourage you to think about it, but you don't have to start with the very big picture of replicating whole humans. You can start with very small challenges and move forward. So you can take a picture of the QR code if you haven't done it already, look at the report. And what you can do, I'm sorry, I ran over time, but think beyond devices and data, understand the mechanisms of health, the mechanisms, instill a culture of ethical inquiry, and seek diverse perspectives, not only from the data, but from the different devices, the methodologies, the stakeholder community. Make sure you include diverse perspectives from the community. Disseminate your principles. You've created 20 years in honing your principles. Share it with the rest of the world. Create curriculum. Develop the workforce. As we've heard in other talks, we really need it in the workforce now, and participate in NIH grants and review. It's a supply and demand culture at NIH, and we really need people like you to be part of it. So thank you very much.